Let's take a look at how to write an equation when given a graph. To write the equation, we just need to look for the same characteristics that we've been looking at. We just need to read them directly from the graph, write them down, and then put them in the general form. 5 basic steps. Find A, find the period, calculate B using the period, calculate D just by looking at the graph, and then we need to look for a phase shift. Look for how much the graph has shifted, if at all, off the general form of the point 0, 0, and use that to calculate your C in your equation. So let's just keep track of those general steps as we work. Also, as I remind you, I work outside a lot, and I think my neighbor is building something, so you may hear some construction going on next door. Just wanted to warn you. All right, so let's take a look at this graph. First thing is going to be A, which, as you remember, is your amplitude. How much does your curve go up and down? You can either just look at that and see what that value is. You can see that it's 1. Or if you'd like to calculate it, you can. It's your max value, which is, in this case, goes up to 1, down to a -1. So max minus the min divided by 2. So we're going to have 1 minus a -1 divided by 2. So you're going to have 1 plus 1 divided by 2, which is going to be 2 divided by 2, which equals 1. So let's just keep track of everything over here. So we're going to have A is equal to 1. Okay, so I'm going to change colors because I like things to be in different colors so they stand out here. So we're going to see A equal to 1 over here. Okay, next thing we're going to look for is the period. So we can either use things that are going through the webbing so that they're easily calculated, or we can use our peaks, our maximum values, whatever you like to use. So you can either use your pi value here, because they are doing the same thing at that value. We're going right up through and starting our curve right there. Or if you like to use your max value, you can do that. We have a value of, we're going through at 1, 2, so our unit is pi over 2 here. So we have pi over 2, 2 pi over 2, 3 pi over 2 is right here. And we're going to go back over here to negative pi over 2. So if we're going to do that calculation, we're going to have negative pi over 2 here. So there we're going to have we're going to have 3 pi over 2 minus a negative pi over 2. So we're going to have 4 pi over 2, which gives us 2 pi. Now, had I just used where I was going through webbing, I would have had pi minus a negative pi, which would have given me 2 pi. So there's my period of 2 pi. Either way, I get the same thing, which is what I wanted to see. So with a period of 2 pi, I can calculate B. So that's why I calculate my period. So that's step 3. So the formula for period is if you recall, period equals 2 pi over B. So I'm going to use that to find B because that's another component of my equation that I need. So I'm going to say 2 pi equals 2 pi over B. And I'm going to solve that for B. So if I cross multiply, I get 2 pi B equals 2 pi. Divide both sides by 2 pi. And I get B equals 1. So keeping a running tally over here, I get B equals 1. All right, so now the next thing to do would be calculate D. And D is how much do I shift up and down off of the x-axis. Well, in this case, I don't shift at all up and down off the x-axis. My center midline is right there through the x-axis. So my D value is 0. And I skipped C and went straight to D just because D is so easy to calculate. And C takes a little more work. And I thought I would just do that because it's quite simple. All right, now for C, calculating C, first thing I need to do to calculate C, I need to look to see if there's any type of phase shift. In other words, does my usual or my general sine curve shift at all from its general starting point of 0, 0, which is usually starts right here and goes up, okay? Well, it does. It shifts and starts actually right here. We could say that it starts right here at pi. So we actually have a phase shift starting over here at pi. So what we can do is, remember, earlier we learned that the formula for phase shift is equal to negative c over absolute value of b. So that really handy formula is going to help us find our last remaining value in our equation of c. So what we'll do is we'll say our phase shift of pi is equal to negative c over absolute value of b, which we know b is 1, and we're going to solve for that unknown value of c. So pi over 1, cross multiply, we get negative c equals pi. But we don't want negative c, we want c. Oh, look, somebody's going by and honking. We want c. So if we divide by negative 1, we get negative pi. C is equal to negative pi. Pi, sorry. All right, so now we're going to put it all together. C equal to negative pi. Let's put it all together and put it into an equation. So my equation is going to be f of x equals a, which is 1, I don't need to write it, sine bx, which my b is 1, again, I don't need to write it, my vertical shift, which is, and I shouldn't have put that parenthesis there, let me get rid of it. My vertical shift is minus pi, and I don't have any, phase shift, I'm sorry, my horizontal shift is minus pi. My vertical shift is 0 plus 0. I don't need to write it, but that's what that would be, plus 0. So I get to take that right off there. And that's what my equation would look like in that case. So let's take a look at another one. So let's say our graph looks like this one. Again, the steps are the same. Find A, the period, B, D, and C. So A is going to be from 1 to negative 1, so that gives us an A value equal to 1. So A is equal to 1 from here to here. Okay, 1 minus a negative 1 is 2. 2 divided by 2 is 1. In this case, the period is going to go from, let's do max to max. So let's do, because that's already set up for us. So let's do 4 pi to 0. So we're going to do 4 pi minus 0. So the period in this case is 4 pi. So now let's calculate b. So b in this case is going to be 4 pi over 1 is equal to 2 pi over b. So I'm going to get 4 pi, b is equal to 2 pi. And b is going to be equal to 2 pi over 4 pi, which is equal to 1/2. So b equal to 1/2. So then let's calculate d. How much do we shift off of the horizontal axis? Do I shift up or down from the midline here off of the x-axis? And I don't. In this case, d is 0 again. So I don't shift up and down again. So now let's look for a phase shift. How much do I shift off of my starting point of 0, 0? Do I start anywhere other than 0, 0? And you could choose a different spot other than 3 pi. and you'll work out fine because there's multiple equations that would work here, but it's convenient here to start with 3 pi. So let's start with 3 pi. So if I start with 3 pi, remember phase shift equals negative c over absolute value of b. We're going to say 3 pi equals negative c over absolute value of b, which is 1/2. So solve for c. This is going to be over 1. Multiply, cross multiply. So we're going to get 3 pi times 1/2. So when we cross multiply there, we're going to have 3 pi times 1/2 equals negative c. That's going to give us 3 pi over 2 equals negative c. But we don't want negative c, we want c, so divide by negative 1, and that's going to give us negative 3 pi over 2 equals c. So now we've got every component that we need. So let's go ahead and write our equation. We're going to have f of x equals sine, a is 1, 1/2 x minus 3 pi over 2 plus 0. And that's the equation for that particular sine function. So let's try another. All right, starting with amplitude. The maximum height here is -2. The minimum is -4. So calculating that, we're going to have -2 minus a -4. Okay, I got to tell you, normally it's pretty quiet out here, but we're constructing a barn across the street. Dogs are barking. The traffic is 5,000 cars today. -2 minus a -4 is going to be 6 over 2. We're going to have 3. So our amplitude, no wait, clearly I can't add. It's all the distractions. So -2 plus 4 is going to be 2 over 2. It's going to equal 1. All right, so our amplitude is 1, so A equals 1. All right, so let's see, find the period. So our period is going to be, let's see, we're going to go in units of 1, 2, 3, 4. So pi over 4 are going to be our units. So we can do our peaks, I would say, because we don't have anything good over webbing that I see. So let's do pi over 4. So let's do, all right, here's pi over 4 here. So this one's pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. So we're going to do 7 pi over 4 and 3 pi over 4. All right, so 7 pi over 4 minus 3 pi over 4. That's going to give us 4 pi over 4, which is pi. So we have a period of pi. And you could have used this one and this one. And that would have been fine too. You've gotten the same thing. So we have a period of pi, which we can use to calculate b. So pi over 1 equals 2 pi over b. And if we cross multiply, we get pi b equals 2 pi. So if we divide by pi, we get b equals 2. So we have a b of 2. Calculate d. How much do we shift? So here's our midline. So off of the x-axis, we shift down 3. So our d is going to be -3 this time. So we have a d of minus 3. Now, how much do we phase shift? How much do we shift over? Let's see. So how much do we shift off of if we're gonna not start going up here? I'm gonna call it right here. I'm gonna use that as my start. So we call that, so if we're not pi over 4, 2 pi over 4. So we're gonna call that 2 pi over 4 for our phase shift, which is pi over 2. So we're going to say phase shift of pi over 2. So we're going to have pi over 2 equals negative c over absolute value of b, which we said is 2. So we're going to have 2 pi equals negative 2c. Divide both sides by negative 2. And we're going to get c equals negative pi. So now we have everything we need to write our equation. So we can have f of x equals 1. So we're going to have sine, and b is 2. X, phase shift, or c, is negative pi. And then minus 3 for d. So there's your equation. Let's see, I think I have one more on here. Okay, so let's take a look here. For A, our max is 3, our min is negative 1, which gives us an amplitude of 3 minus negative 1 over 2, 4 over 2 equals 2. So A equals 2. Our period on this particular problem, let's see, do we have anything going through webbing? We don't. So we're going to have our unit of 1, 2, 3, 4 of pi over 4. So we're going to have pi over 4 here. 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So we can use that to calculate our period. So 5 pi over 4 minus pi over 4 gives us 4 pi over 4. Cross out the 4. So our period, don't know why I just wrote all that out, is pi. So now we can calculate b. Pi over 1 equals 2 pi over b. Pi b is equal to 2 pi. And, you know, these generally end up being the same things over and over again, so just keep a little note card with what b equals when your period is pi, or 2 pi, or 4 pi, or 3 pi. So you don't have to keep calculating it over and over again. So whenever the period is pi, you'll know right away that b is equal to 2. Okay? Don't make yourself crazy calculating it over and over again. So b is equal to 2, a equal to 2. So calculate d next. So your vertical shift here is going to be how much do we shift off of the x-axis. So in this case, I shift up, looks like 1.5. It looks like, no, wait a minute. I think I just shift up 1. Did I draw that up too high? I think I just shift up 1. Yeah, I'm just up 1. Looks like, let's calculate that. Let's see, negative 1 and 3. Sometimes it's deceiving when there's some above and some below, so it's good that we can calculate it mathematically. So we've got 3 plus negative 1 divided by 2. So we're going to have 2 over 2 equals 1. So yeah, it is just 1. So let's go with, it's just 1. Ignore this one. Yeah, sometimes, at least for me, and you guys know I'm delirious sometimes. So the midline is right here. It's easier if it's all above or all below, but if there's some of it below and some above, I think sometimes it can be deceiving. So if you're not sure, go ahead and just calculate it. All right, so your D is going to be equal to 1. All right, last thing, go ahead and do your phase shift. Now on this one, there isn't a phase shift. If you were to drop this back down, you can see that's going to go right back through at 0, 0. It's going to start at 0, 0. You can drop that back down at 0, 0. So you don't even need to do phase shift on this one. There is no phase shift. So go ahead and just save yourself the trouble. There's no phase shift there. So you've got everything you need. C is equal to 0. So go ahead and just write your equation. You've got f of x equals, a is 2, so you've got 2 sine, b is 2x, no phase shift, so nothing right there, plus 1. And you are done with that particular one. So I hope this helped. Let me know if you've got any questions.